Let us see how we can build a spam detection system using NLP. To start with, we would gather relevant data, collecting emails from existing email systems after taking appropriate consent of the users. These emails would be a mix of spam and not spam emails, of course. Now, we can engineer features from this data. For example, we can use regular expressions to determine if there are any links or phone numbers. We then convert the message into lowercase, then we remove stop words and punctuations. Now, we tokenize this text and split it into individual words. Each unique token in the text is an input to further feature engineering. We take these tokens and convert them into vectors which act as the input to our machine learning block. Once we have pre-processed and feature engineered the data, we can build machine learning models. The model is meant to learn how the features influence an email to be marked as a spam or not spam. So now we hope you have an idea of how you can use different NLP techniques to build intelligent systems that processes the natural languages. In general, this diagram summarizes the different stages in building an intelligent NLP system. The system could be a spam detector, a translator, or even a sentiment analyzer or any other as well.
Shekhar, remember how you were talking about ambiguities in natural language?
Yeah, I do.
So I thought about it and realized that in whatever applications we were discussing so far, these issues could still be persistent.
That's correct. So let's say I was building a machine translation system and there were these two queries to translate. Like one, Google is headquartered in California, and two, Google the headquarters of Infosys. So here you can see the first sentence I've used Google as a noun, and in the second I've used it as a verb. And there's a pretty significant difference when a machine is going to translate these two sentences.
How will this work?
That's an interesting question. So here the ambiguity is in the part of speech tagging module of the pipeline. So consequently we need to have a better and a more accurate part of speech tagging.
How do you think this can be achieved?
Let's ask our learners.
You might have figured that choosing a part of speech based on the neighboring words is a better option than going with the most common parts of speech tag.
This is because a word's meaning can change based on its context. Let's take a look at how POS tagging based on neighboring words can be performed.
To do this, let's consider these sentences. We shall also assume that the text is already annotated manually by linguists.
Let's now identify pairs of words in the sentence. A pair of words can be referred to as bigrams.
Now, we can build a probabilistic model to predict the POS of Google based on its neighboring words.
This is just an illustration of how we can create a model. The actual model, of course, would do this over millions of lines of text and be as general as possible.
To add to that, I would highly recommend that you take a look at this website to see a POS tagger in action.
So now we have an idea of how we could go about solving the problem. This idea can be applied to several applications where we want to determine an annotation based on the context.
You could also consider that increasing the number of neighboring words that form the context is likely to improve the model's accuracy.
Another related problem could be determining the meaning of a word after having determined its part of speech. For this, we can use WordNet, which is a large lexical database for English.
The NLP community has several pre-built models or solutions for these common tasks. We will discuss them in a later section of this course.
Part of Speech Tagger and WordNet are excellent resources, but setting them up has been done over decades with so much manual effort going into annotating the text and preparing the data.
As humans, we have a much more intuitive understanding of languages, and I think that we are much more efficient than computers.
You're totally right, Shweta. Humans have a very intuitive understanding of language, and we're able to determine features and patterns in abstract ways. This is an area where deep learning is making an impact. So let's see what kind of advances in NLP are being made using deep learning techniques. Most of you might have used Google Translate at least once. If you haven't, then I hope you will after watching this video. Originally, Google Translate used a phrase-based translation system. This system would translate words and phrases within sentences and was at times infamous for its mistranslations. Then in 2016, they replaced this translation system with a deep learning system called Google's Neural Machine Translation. The newer system reduced the errors by an average of 60% compared to its predecessor. In fact, the system got as good as humans in a few languages. Another application that you might be using is the SwiftKey keyboard on your mobile device. SwiftKey also uses deep neural networks that look further into your sentences before making predictions. SwiftKey replaced their next word prediction system from a statistical n-gram model to the deep neural network and more accurate recommendations as you type. The table here summarizes the performance of deep learning systems for various NLP tasks. Take a look. Now you know deep learning for NLP is so much more advanced, and I'm sure you'd want to try it out.
Congratulations! You have made it to the end of this course.
We've been through a lot of material in this course, and it's time to reflect on what we've learned.
You should now be able to explain what is natural language processing and appreciate how it is changing our lives.
You should also be able to describe various techniques used in the field of NLP and compare different software, platforms, tools, and frameworks that are used to build NLP solutions.
Next time you're typing a query to a chatbot or searching on Google, I'm sure you will remember how NLP is a game changer in the business world. Happy learning!
Thank you.